Alright, wasabi you guys. I'm gonna start doing some example solves for integration by parts. So I have this formula right here. I don't know if you can, I don't think it can show my cursor, but I'm just gonna, let me just use a brush. So if my pen thing works, okay. So the majority of you guys are mainly use this formula, but I mostly use this just because it's just simpler for me. Uh, it just is. So I am mostly gonna be using this formula. Okay, and then either way, it should like work out the same way. So yeah. So let's go ahead and get to the first problem, the first example. Okay, so we have x squared and sine 2x. So the best thing to do is to always derive a polynomial. Always derive a polynomial. This x squared here is pretty much considered a polynomial. So I would want to derive that. And the reason is because when you derive it, when you keep deriving it, it will reach to 0. And that's something that you would always want. There are exceptions, and we'll get to that later. So I want to derive x squared, and I want to integrate sine 2x. And so when I derive x squared, you get 2x. When I integrate sine 2x, you should get should be like negative cosine 2x. Oh, and because there's a 2, you multiply, or you divide the constant. So it'll be divided by 2. Okay. So now that we got that, we could just go ahead and easily set this up. We get negative cosine 2x. Well, let me write it this way. Negative x squared cosine 2x all divided by 2. And then we get minus, oh, well, we have this negative here. So if we plug this in, we're going to get positive, and then 2x cosine of 2x times a half. And these two cancels out. Okay. So we got this 2 here. So this is pretty much what we have left, right? If I can erase this quickly. Okay. So now we have another integral. Do we have to do integration by parts again? Yes, because we have this x here. I know it's tedious, but you just got to do it. So we're going to go ahead. We're going to leave this here by itself. We have this integral. We're going to do integration by parts again. Okay, no problem. I want to derive that x. And my g prime, I want to integrate cosine of 2x. Okay. Then we go ahead and do our derivative here. That's just 1. Integral should be half of sine 2x. Okay. Because the integral of cosine is sine, and then because it's 2x, you just divide 2. And then we go ahead and do the formation. Oh, I'm going to leave that there. So this becomes FG. So that's x over 2 sine 2x. And then minus, and then all we have to do is integrate this half, sine 2x, which is equal, well, let me actually do it this way. So let me write these two answers first. Just cosine 2x, 2 plus x over 2 sine 2x. Okay. And then the integral of this, don't forget the negative, so it'll be negative half sine 2x, which is, the integral of negative sine is cosine. So this would be, so you should get like 1/4 cosine of 2x. Okay. You have this half, this 2 divides again, and then the integral of sine is negative cosine, so the negative cancels out. Or you can say it as integral of negative sine, and that would give you positive cosine. And then this should be your entire answer. This whole portion. Okay? All right, let's do the second one. Okay, so this time we have bounds. It's no problem. So we're not going to worry about that yet. That bounds are always just last and easy to you just plug it in, So let's work on integrating by parts. So we're going to derive the polynomial as always. So f is x squared plus 1. I want to integrate e to the negative x. So I want to derive x squared plus 1. And I want to integrate e to the power of negative x. So now I derive it. This is just 2x. When I integrate, this is just negative e to the negative x. This negative it's like negative 1. Like it's a constant. So when you divide it, it's just negative. Okay? And so this forms your integral. So you should get negative e to the power of negative x times x squared plus 1 minus, because this negative here will make us positive. So we should get, let me rewrite it this way. So we should get 2x e to the negative x, just like that. Okay. And then we're going to have to, of course, integrate by parts again. So again, I always want to derive polynomial. So I'm going to derive, you can, you could derive 2x or x, it doesn't matter. If you're going to derive x, just don't forget about that 2 constant. Or you could just derive 2x. I'm just going to derive 2x. So, I want to integrate e to the negative x. And so when I derive this, this is just 2. And then g here, same thing. So I'm just going to put this, I'm just going to write it at the bottom here. So then this becomes, this actually becomes negative e, or negative 2x e to the power of negative x. And then minus, that negative is going to cancel out, that negative is, this negative here is going to make this become positive. And then 2e negative x dx. And this is a simple integral, very simple integral. So this is pretty much just negative 2 e to the negative x, right? So let me just write that down. Okay. Cool. I'm gonna put this down. Okay. Cool. So this was our integral, our antiderivative. And now I'm going to start plugging in bounds. So when I plug in 1, and put parentheses, I get e to the power of negative 1, that's 1 over e. Okay, e to the negative 1 is equal to 1 over e. Oops, okay. And then x squared, so 1 squared plus 1, that's 2. So it's 2. Minus, 2, 1 over e again, because the negative 1, and then minus 2 over e as well, again. Okay. Wow. And then minus, another big parentheses, and then we just plug in 0. E, well, negative 0 is just 0. E to the 0 is 1, so this would equal to negative 1. Okay, so we have negative 1. X squared plus 1, so plugging in 0, that will just give us 1. And then this is 0, because that x is there. And then minus 2e 0, which is 1, so we'll get like this. So simplifying this is like 2 plus, so this is like negative 6 over e, right? Then minus, and then we have like negative 1, just like negative 3 here. So our answer should be 3 minus 6 over e. Just like that. Okay. Let me just double check to make sure that it is correct. And it is correct. Okay, cool. So that's that problem. All right, let's do the third problem. Okay, so now we're getting to the exception part. So this is where we don't want to derive a polynomial, is because if we derive a polynomial, then we're gonna have to, this puts us in a position where we have to integrate ln of x. But this is complicated. So this just gives you another, integration by parts. But instead, so when you have a case like this, where it's a polynomial and then ln of x, you do ln of x first. Ln of x is always first. I mean, not first. Ln of x will always be derived. You always derive ln of x. And then you integrate the polynomial. The reason is because when you derive ln of x, it's just 1 over x. And when you integrate a polynomial, it's just going to be another polynomial, which in this case, 1/5 x to the power of 5. Okay, and of course, when you do f prime of g, which states here, f prime g, it's just another polynomial, and so working with this way is a lot easier. So we're going to go ahead and do our setup. So we have 1/5 x to the power of 5 ln of x. Okay, now when you do antiderivatives, doing ln of x, it has to be absolute value. And then minus integral of 1/5 of x to the power of 5 times 1 over x dx. And this portion simplifies, or I'll do it this way. This actually simplifies, to x to the power of 4, right? And it's a simple integral. You just do power rule, right? So this, now we could just rewrite this as x5 ln x minus, and then the power rule again, plus c, and then you're all done. Just like that. So this is the only exception where you integrate the polynomial so that you can derive ln of x. And it's better this way because ln of x, well, the derivative of ln of x is just 1 over x. And this x is just it just pretty much simplifies your bigger polynomial. Okay? All right. Let's do next example. Okay, so when you first see this, you're probably intimidated, but don't worry. When you see something very intimidating, don't panic. So with this kind of trick, it works the same concept as like how you integrated inverse tangent, right? You see this, you were a little intimidated. It looks like it's only one function, right? And just like how you integrate this integral, you derive inverse tangent, and you just integrate. What did you integrate? You technically integrated 1, and then you do, you continue, and then it turns out that the integral was not as bad as you thought. You end up with this. Let me actually complete this. You end up with this, and then you solve it. It was not as bad. This is the same concept that we're about to do right now. Okay. So it looks like it's just one function, but we could sort of go around this. So we're going to derive ln square. we're going to derive ln squared, and I'm going to integrate 1. What is the derivative of this? Well, the derivative, if you remember the chain rule, okay, the derivative of ln squared, well, the ln is being squared, so this power is out of the way, so we have to derive the power. So power rule, ln of x. And then you derive the inside, which is ln of x. So the derivative of ln of x is 1 over x. So times 1 over x. So to sort of redo this again, it's like power rule. So it's 2 ln of x, right? And then it's 1, which is, itself. And then you derive the inside, which is, the derivative of ln of x is 1 over x. Okay? And this is your derivative. That's how the chain rule works. The chain rule works. Okay? And then integrating this is just x. Right? So now what? So now we go ahead, do our formation, we set it up. We have ln squared minus the integral of 2 ln of x times x. The x's cancels out, right? So we pretty much just get this instead. Okay, so now what? You just do integration by parts again. It's the same concept again, literally. So we go ahead, derive ln of x, and integrate 1. And so the derivative here is just 1 over x. Integrate 1, it's just x. And so now this becomes -2. I'm going to put parentheses. I'm going to put parentheses here. So we just have x ln of x minus the integral of 1 over x times x, which literally cancels out to just what? This is just 1 dx. We know what 1 dx, we know the integral of 1, it's just x. So this is what we have. And now we just combine it together. So if we combine it together, this is technically our answer. You could go ahead and simplify it even further. And this is -2x ln of x. And then this negative distributes. So it will be positive x plus c. This should be the answer. Okay? Very good so far. Not as bad. Okay? Last example. Okay. Again, this time I'm going to give you the derivative for this one. So the derivative of secant, the derivative of inverse secant, I don't think Dr. Tran expects you to memorize this, so I'll give this to you as given. Okay. All right, so I'm just going to cloud this. Okay. So you have that information. Cool. So now how do we integrate this? Okay, again, there are exceptions to polynomials. So mainly the only situation where you don't derive polynomials is if you have inverse functions. Pretty much. That's mainly how it just goes. You're not going to get anything complicated or ugly. Otherwise, that wouldn't be Calc 2. It would be some monstrosity level. But mainly, you'll only get these kind of integrals where it's either a polynomial with some other functions or a polynomial with an inverse function. ln of x is technically considered an inverse function because it's the inverse of e to the x. So the only time you don't derive a polynomial is if you have an inverse function, okay? The majority of the time. There are sometimes where it's the other way, but that's very rare, and you're not going to be given that because it's, you know, it's advanced. You will not be given that kind of stuff. So here, we're going to go ahead and derive our inverse. So I want to derive the inverse of secant x, and I want to integrate 2x. Then, of course, we're given the derivative, which is 1 over x times the square root of x squared minus 1. And then here, when we integrate 2x, this is just x squared. Cool. Let's form our integral, our formation. So x squared inverse secant minus the integral of x squared times 1 over this. And what's awesome about this is that we can simplify it. This x squared and this x here, they cancel out, so you pretty much have, this is our simplified form. I'm just going to rewrite it. So that's our simplified form. And here, it's just basic U-substitution. So if you don't remember, it's okay, I can walk you through it. So I'm going to go ahead and let u equal the inside of this square root here. And the reason why I want to do x squared minus 1 is because this x here would be our derivative. So du is equal to 2x. We have the x right here. And so when we go ahead and do it, we have root u here, and then x. Sorry, this should be dx. So when we do dx, du, we have du 2x, because technically this is du over 2x equal to dx, right? So that's where this comes from. That's where this comes from. And then this x cancels out. Okay. And then it's just du over 2 root u, which you should get root u. So after doing all that u substitution, this is technically, your answer should get x squared over secant. So because we ended with u and u is equal to x squared minus 1, so your answer would just becomes x squared minus 1. Let me write that nicely. X squared minus 1. Okay. So this is pretty much our answer right here. Okay? Just like that. And there you go. That's how you do integration by parts. There is another type that we will learn in the future. We won't get to that yet, but I don't know when Dr. Trent might teach the other type of integration by parts, but just don't worry much about it. It's not that bad. These 5 examples that I gave are very good basic integration by parts to know. All right. I hope that helps. And yeah.